explore some more examples together. Destination-based forwarding could be performed in the generalized forwarding by only setting the rule for the destination IP address in the flow table, setting the action as a port to forward the packet to. Second, imagine we want to implement firewall functionality to limit the incoming traffic to a host. Firewall functionality could be achieved by drop rule based on different fields matched. For example, we can limit TCP incoming packets to a specific port. For example, port 22 to limit SSH possibility. Or we can drop packets coming from a specific source. For example, 128.119.1.1, probably because it is detected malicious. The rules to match TCP header fields was used in the first and the IP datagram header fields in the second firewall example, both possible in the generalized forwarding using OpenFlow. It is also possible to perform matching based on layer 2 headers. For example, layer 2 frames with a given destination MAC address could be forwarded to output port 3 to achieve a switching function using generalized forwarding. What is performed on all of the generalized forwarding examples we saw from OpenFlow is matching a pattern followed by performing an action. The generalized forwarder can act as a router when matching is performed based on longest destination IP prefix and the action is forwarding out a given port. It can act as a switch when matching is performed based on destination MAC address and action is forward or flood. It can act as a firewall when matching is performed based on IP addresses or TCP or UDP port numbers, and the action is permit or deny. And it can act as a network address translation router when match is performed based on IP address and port, and the action is rewriting the address and port. And our last detailed generalized forwarding example. Assume we want the datagrams from host H5 and H6 to be sent to H3 and H4. And this needs to be performed through S1 and from there to S2. OpenFlow controller will write the tables on S1, S2, and S3. H5 and H6 are connected to router S3. At the router S3, we need to define the rules that forward the datagrams based on their destination to S1. This means they should be sent out to port 3. Which packets, though? All packets with a destination with first 16 bits matching 10.2, as that is what matches H3 and H4, and has the source address with first 16 bits matching 10.3 because that is what matches H5 and H6. At S1, we need a similar matching pattern with the action set to forward the datagrams to port 4. Note the additional matching pattern, including ingress port to ensure that the packets are coming from S3 on ingress port 1. At S2, we need a similar matching pattern on the ingress port, ensuring datagrams are coming from ingress port 2 connected to S1, with more specific rules on each of the destinations that forward the packets to each of the H3 and H4 through the port they are connected to the router.